Welcome to the show. Andrew, you talked about AIOps and autonomous networks. Is that real, autonomous networks? What's your view on autonomous networks in the telco industry?
Yes, it is real, I'm glad to say, but how mature are organisations going down the path of autonomous networks? That's probably the better question. We're definitely working with our customers around autonomous networks. We're definitely working with them around AIOps, and how those two things come together is how telcos and operators can save money and create better efficiencies. How can we do things better and more efficiently and smoother using the smarts and the logic from AI and taking away, as I said, the element of human error or the possibility of human errors just to automate things. That's AIOps. MLOps is really about what do we do with all these AI models? How do we lifecycle them? How do we make sure they're secure? How do we make sure the data isn't going stale? Just like we lifecycle applications today in containers, we need to think about lifecycling AI models. And at Red Hat, we believe that AI models will proliferate. You know, there will be more and more models in organisations as we move into the future. And so we need to think about managing those models. That's where MLOps comes in, right? It's teams that understand those models, they know how to lifecycle them, they know how to manage them, and have them operating on an efficient platform, right? That helps administrators with that task. You hit on a key topic there, observability. So most of the data we see in telco networks is coming from the observability tools that a lot of telcos already have, right? They work with their network equipment providers or their OSS providers, and they get a lot of these tools that give them the metrics and give them the alerts and the alarms around the networks, and often in NOCs, etc. They'll be dealing with a lot of this information. It can be an enormous amount of information, and that's where AI comes in, because it needs to be able to sift through that information and find signal in the noise, find patterns in the noise, right? And so once we can determine those patterns and we've fine-tuned our models to detect anomalies, predict what's going to happen next, that's where the automation can really kick in and take action based on that intelligence. We talk about event-driven automation as in, if you contrast it against a human-initiated automation, right? So in the past, most automation was a workbook or a playbook that was written by humans, and there will be always a human that had to cast an eye and make a determination, should we run this automation playbook, this workflow? In event-driven automation, the automation workflows are kicked off by event in the network or something happening, an alarm, a switch goes down or a port turns off, etc. We can take that using our observability tools, that information, and kick off a whole automation train to remediate that problem, right? Without a human getting involved in the whole chain. It could even open a ticket at the end and say it's been closed off, or alert someone or send an email. So event-driven automation is key to some of these advanced autonomous network concepts that we're talking about. And at the end of it, we're not doing automation for the sake of automation, right? We want to have an outcome, or there's a business goal or something. And sustainability is one of the biggest topics at the moment, right? Everybody's talking about reducing carbon footprint. A lot of senior execs have KPIs and key metrics around this topic. So if we can use automation to create energy efficiency, for instance, reduce the carbon footprint in a network. Think of a network maybe as a lot of workloads distributed across a geographic area. If we can measure that to a very precise metric on how much power is being consumed, what's the carbon footprint, we can make determinations on, where does the workload need to sit, or where could it sit more efficiently. Maybe there's, green power being generated in this part of the network, but not in this part of the network, and we could potentially move a workload from this part of the network to another part of the network and save on our carbon footprint. And that's a key metric that people are measuring today. So not only that, there's a cost element too, right? Energy has a cost. It's a cost that's going up. In telco, the RAN is probably one of the biggest users of power in most industries across the country. So if we can save even just a fraction of that power consumption and that power bill by making smart decisions around where workloads live, it's a potential cost savings could be enormous. So we do that with an open source project called Project Kepler. It's been one of the key tools that we've been using in some of our experiments with our customers and our partners. But there's a lot of other tools as well to measure this at a very finite level that doesn't have an impact on the existing network as well. So it's exciting times, and it's definitely going in the right direction.
Excellent. Well, thank you very much, Andrew McGee, Senior Director from our Global Telco CoE. Thanks for your time, and yeah, enjoy the rest of the event, Andrew.
Thanks, Andres.